In physics, we were doing electric dipole. So topic is electric dipole. Electric dipole. What is electric dipole? Electric dipole is a system in which we have two charge with same magnitude but opposite sign. So this is minus q, this is plus q, and separation between the charges is 2L or distance d. For any electric dipole, we define dipole moment. Dipole moment is equals to P is equals to charge into separation between them. Dipole moment in vector form is given by charge into distance 2L. L will be in vector form. And dipole moment is vector quantity, so it will have a certain direction. In physics, its direction is negative to positive. And in chemistry, its direction is positive to negative. Its SI unit will be what? SI unit. Charge is given in coulombs and distance in meter. So its SI unit will be coulomb meter. Next, its dimensional formula. So its dimension will be for charge we have AT and for distance we have L. So this will be LAT. Understood? Next point is values of electric field and electric potential on axial line and equatorial line of a dipole. So let's say this is an electric dipole with charge minus q and plus q, and there is a point in space. It may be anywhere. Let's say this is point P. This is the midpoint of the dipole. Let's say this angle is theta. So what will be the value of electric field at point P, which is at an angle of theta from the axis of dipole? If you will join the charge minus q to plus q, the line segment will be dipole axis. So angle is taken from dipole axis theta. And the formula will be E is equals to 1 upon 4 pi epsilon naught P by R cube square root of 1 plus 3 cos square theta. This formula is valid for all the cases, equatorial, axial, or any other case. Potential is 1 by 4 pi epsilon naught P by R square cos theta. Formula will work for any case. For any point in space, if you want to have electric field and potential, we can apply the formula, provided we know the value of theta. So E is 1 upon 4 pi epsilon naught P upon R cube into square root of 1 plus 3 cos square theta. And for potential V, we have 1 upon 4 pi epsilon naught P cos theta upon R square. Let us discuss two standard or special case of this formula. First one is, if we have a dipole minus q2 plus q, and there is a point on dipole axis, point P, and at this point P, we want to know the value of electric field E and potential V. So if you will look at the condition, theta is the angle between midpoint and point of interest. If you will join the line between the points, midpoint of the dipole and point of interest P, then the angle is theta. So if I take this point P at this point Q, this angle will be how much? 0. So in this case, this is known as axial position, and in axial position, theta will be 0. So we will substitute the value of theta in the formula, which is 1 upon 4 pi epsilon naught P upon R cube square root of 1 plus 3 cos square theta, that is cos square 0. Cos square 0 will be what? Cos 0 is 1. So I think this will be P upon R cube. Cos 0 is 1, so this will be 3 into 1, 3 plus 1, 4, and square root of 4 will be 2. So E will be at axial position 2P upon R cube. Understood? The value of E at axial position will be 1 upon 4 pi epsilon naught 2P upon R cube. Now what will be the value of potential V? So potential V is given by 1 upon 4 pi epsilon naught P cos theta by R square. On substituting the value of theta, it will be 1 upon 4 pi epsilon naught P cos 0 upon R square. Cos 0 is 1. So V axial will be 1 upon 4 pi epsilon naught P upon R square. So these are the two standard formulae for electric field and potential at axial position. Understood? Yes. Next case is, if the point is on equatorial position. What is equatorial position? So let's say this is electric dipole minus q2 plus q, and there is a point which is at a line which is perpendicular bisector of the dipole axis, and at this line, at any point, we have to find out the value of E and V. Point may be anywhere. Point may be this point P, or it may be here, any another point Q, or this may be the point of interest R. The distance from the midpoint of the point of interest, let's say this distance is R, as in this case, from the midpoint, this distance is R. So distance will be taken from midpoint. And in this case, if you are looking for the value of theta, that will be 90 degree. So we can substitute the value of theta in the formula. What will be E? Electric field E is given by 1 by 4 pi epsilon naught P upon R cube square root of 1 plus 3 cos square theta. This is a standard formula for any case. And if you are taking it at equatorial position, then this will be 1 upon 4 pi epsilon naught P upon R cube square root of 1 plus 3 cos square. In this case, theta is 90 degree. Cos 90 is 0. So result will be E equals to 1 upon 4 pi epsilon naught P upon R cube. This is the formula for equatorial position. And if you want to have potential V at equatorial position, which will be given by 1 upon 4 pi epsilon naught P cos theta upon R square. Substitute the value of theta. This will be 1 upon 4 pi epsilon naught P cos 90 divided by R square. Again, cos 90 is 0. So potential will be 0. So these are two special cases for dipole, equatorial and axial. If you will compare the results at equatorial position and axial position, you will get it as E axial is 1 upon 4 pi epsilon naught 2p upon r cube, and E equatorial is 1 upon 4 pi epsilon naught p upon r cube. So what is the relation between them? We can clearly state that electric field at axial position is double of electric field at equatorial position. Now let's look at potential. Potential at axial position is 1 upon 4 pi epsilon naught P upon R square, and potential at equatorial position is 0. So there is no relation between V and VE. VE is 0. V is 0 means if you will take any point, point P or point Q or point R, at all these points the value of electric potential will be 0. Understood? Or any doubt? Okay, next we can discuss about what is potential energy of a dipole in uniform electric field. Potential energy of dipole in electric field, and electric field E is uniform. Electric field E is uniform. In this case, let's say this is electric field E, uniform electric field, and there is a dipole which is placed inside the electric field. Let's say this is minus Q and this is plus Q, and we have to find out the potential energy if this dipole is rotated by an angle of theta. So potential energy in this case is given by U is equals to minus PE cos theta, which will be in vector form. U is equals to minus vector P dot vector E. So if you want to have the potential energy of the dipole, you just have to get the information about angle theta. If you know the value of theta, you can directly calculate potential energy of the dipole. Understood or any doubt? Next is what will be torque on the dipole. If we have a dipole which is placed in a uniform external electric field, what will be torque? So next point is torque on dipole in electric field E. Again, electric field E is uniform. Let's say this is electric field, uniform electric field E, and dipole is placed like this. And let's say the angle between dipole axis, this is dipole axis or dipole P, and this is electric field E. Let's say this angle is theta. This angle is theta. So torque is given by, in this case, torque is given by PE sine theta, which will be in vector form P cross E. So torque is given by PE sine theta or P cross E. In this formula, P is dipole moment, that is charge into distance. E is electric field, and theta is the angle between P vector and E vector. Similarly, it is true in case of potential energy. If this is the direction of dipole moment, negative to positive is dipole moment P, and this is electric field E, and angle is theta between them. So potential energy is given by minus P cos theta, that is vector P dot vector E. Understood? Understood or any doubt? Okay, next point is, if we rotate electric dipole from an angle theta 1 to angle theta 2, what will be the work done? Question will be like this: find the work done in in rotating a dipole from angle theta 1 to theta 2 in electric field E. Important point is, in this case also, electric field E is uniform. Basically, in 12th class, all the dipole concepts are for uniform electric field. So question is like this: we have uniform electric field E, and let's say there is a dipole with dipole moment P in direction negative to positive, and it makes certain angle with electric field E. Let's say this angle is theta 1 or initial angle. Now I rotate the dipole and take it at another position. Now the dipole is at this position, minus Q plus Q, and angle is changed from theta 1 to theta 2. So we want to know what will be the work done in rotating it from angle theta 1 to theta 2. So work done in this case is given by theta I is theta 1, and after rotation theta final is theta 2. Want to know the work done? Work done will be given by the formula work done W is equals to PE in bracket cos theta 1 minus cos theta 2. So if you know the initial angle and angle after rotation, we can find out the work done in the process. Understood or any doubt? Yes. Next point is electric potential energy. Electric potential energy electric potential energy of a system of point charges. First of all, we will have the basic formula. We know that electric potential V is given by W by Q. And this work done W can be taken as potential energy U divided by Q. So from this simple or basic concept, we have potential energy of a point charge, which is given by magnitude of the charge and potential at which point this charge is present. This concept works in this sense. Let's say this is a region in which electric field is present, and in this electric field there is a point P which has potential Vp, and there is a charge Q at infinity which is taken from infinity to this point by any path. It doesn't matter whatever be the path, the value of the potential energy will be same. So we know that to take it from infinity to point P, we have to do some work W, and this work done will be stored as the potential energy. So V at point P is given by W by Q, which is same as U by Q. So U will be magnitude of the charge which we are taking from infinity to point P, and multiply it by the potential of the point P in the electric field. What will be the potential energy of 2-point charges? The potential energy of 2-point charges. Let's say this is charge Q1, this is charge Q2, maybe positive or negative, and separation between them is R. What will be potential energy of the system? So potential energy of this system will be U equals to 1 upon 4 pi epsilon naught Q1 Q2 by R. This is the potential energy for a system of 2-point charges Q1 and Q2. Remember, in this formula, Q1 and Q2 may be charges with any polarity, may be positive or may be negative. So whenever you will apply the formula, you have to put the value of Q1 and Q2 with proper sign. If it is positive, you have to write positive sign, or if they are negative, you have to write with negative sign. Whatever be the sign of the charge or polarity of the charge, you have to put the same into the formula. Now, if we have 3-point charges, how will you find out the potential energy of this system? So there are 3-point charges Q1, Q2, and Q3 at different distance. Let's say this is the distance between 1 and 2 charge, this is the distance between 2 and 3 charge, and this is the distance between 3 and 1 charge. So potential energy can be given by the summation of potential energy of all the pairs, which means overall potential energy will be potential energy of 1, 2 system, and potential energy due to charge 2 and 3, and potential energy due to charge 1 and 3. So U can be given as 1 upon 4 pi epsilon naught charge Q1 Q2 divided by separation between them plus 1 upon 4 pi epsilon naught charge Q2 Q3 divided by separation between them plus 1 upon 4 pi epsilon naught times charge Q1 and charge Q3 divided by separation between them, which simply means 1 upon 4 pi epsilon naught will be outside of the bracket, and we are left with pair-wise collections of the charges. So if we are given with more than two charges, to find out the potential energy of the system, we will find out the energy by taking all the pairs. How to select the pairs? Well, you know the concept of mathematics for combination. If you are having n object and you have to select two objects out of n object, pairs will be NC2. Similarly, if you have three charges and you want to make them in pairs or you want to select them in pairs, the value will be 3C2. 3C2 gives 3. So this is the concept how we will find out the potential energy of a system in which more than two charges are present. Understood or any doubt?
No doubt, sir.
Okay. So let's take some example. Questions again will be straightforward. Question is, what is the value of potential at a point which is at a distance of 2 meters from the point charge let's say 5 coulomb. This is one part of the question. You have to find out the value of potential at a point which is 2 meters from point charge 5 coulomb. This is one part. Second part is, if I take another charge 2 coulomb from infinity to this point, what will be the work done to do so? So second part of the same question will be, find out the work done to take 2 coulomb charge from infinity to this point. From infinity to this point. Are you getting the question? Are you getting it?
Yes, sir.
Okay, so let me picturize it. Let's say there is a point charge 5 coulomb and there is a point 2 meters from this charge. Let's say the name of the point is A. This is point A. First part is, we have to find out the value of potential at this point. So what will be the formula for potential at point A? Potential at a point due to point charge is given by 1 by 4 pi epsilon naught Q by R. Am I right? Yes. Is it the correct formula to calculate potential at a point due to a isolated point charge? Yes. So what will be the value of VA? 1 upon 4 pi epsilon naught is 9 into 10 raised to power 9. Charge is 5 coulomb. Distance is 2 meters. So basically this will be how much? It will be 45 into 10 raised to power 9 divided by 2, which will give us
2.25.
2.25 times 10 raised to power 9 volt or joule per coulomb. This is first part. Now we have to solve for the second part, which states that there is another point charge 2 coulomb which is at infinity, and you have to take this point charge 2 coulomb from infinity to point A. So to do so, how much work has to be done? We have to find out work done.
Sir,
We know that,
4.5.
yes, we know that potential at any point is defined as work done to carry a charge from infinity to that point divided by charge which we are taking from infinity. So in this case, work done W can be given by simply Q into VA. So this will be how much? Q, which we are taking from infinity, is 2 coulomb. 2 coulomb multiply VA is 2.25 into 10 raised to power 19, which will be again 45 into 10 raised to power 9 joule. Am I right?
Sir, 4.5.
Sir, can you repeat?
4.5.
Sir,
बात मत करें आप लोग, पढ़ाई करें.
Sir, VA will be 22.5.
Okay, VA will be, let me correct it. VA will be 22.5, and on that basis, this will be 45, right? Yes. Okay, any doubt in it? Yes. Do you have any doubt?
Yes, sir. Hello, sir.
Yes.
Sir, how to find V?
How to find
V.
V? For V, we have direct formula. If there is a point charge and point of interest is at a distance of r, charge is q, then the formula for potential at point A is 1 upon 4 pi epsilon naught isolated charge q divided by separation, that is r. We can apply this formula. Understood?
Yes, sir.
Let's have one more question. And the question is like this. We have a system of 4 charges which are placed at the corner of a square. All the charges have same magnitude and separation between them is also same. You have to find out potential energy of this system. So potential energy of this system can be calculated by taking potential energy pairwise. And since we are having total 4 charges, and if we will make pair, this will be 4C2. Total 4C2 pairs will be there. 4C2 is 4 into 3 divided by 2 into 1. So there will be total 6 pairs. So let me write it as potential energy U is equals to 1 upon 4 pi epsilon naught. First pair is, let's say this one. So this will be Q square divided by R plus next pair will be K into these two. Q square by R plus K times these two Q square by R plus K times these two Q square by R. So here we have total 4 pairs. Now we are left with only 2 pairs. Could anyone tell me which 2 charges will make these pairs? Anyone? We have total 6 pairs. 4 pairs I have already selected. What will be the remaining 2 pairs?
Sir, diagonals.
Yes, these will be diagonal pairs. This one and this one. So because we are taking now charges on diagonal, so distance will be changed. It will not be r. In fact, if it is square, this will be root 2 times r. So remaining 2 pair will be k q square upon root 2 r plus k q square upon root 2 r. And now if you will simplify it, you will get 4 times k q square by r plus 2 times k q square by root 2 r. If you will take, I think k q square by r will be common, and we will left with 4 plus root 2. Am I right?
Yes, sir.
And unit will be what? Joule. Understood? So electric dipole is completed and potential is also completed. From electric dipole, question will be again simple. Let's say we have a dipole with charge 2 coulomb. So this will be minus 2 coulomb, this will be plus 2 coulomb, and distance between these two charges is, let's say, 1 meter, or let me write it as 1 centimeter. So the value of 12 will be 1 centimeter. What will be the potential? Sorry, what will be the dipole moment P? Dipole moment P is Q into distance between them. So Q is 2 unit and separation between them is 1 centimeter, which will be 10 raised to power minus 2 meter. So value for P will be 2 into 10 raised to power minus 2 meter. Right? This is first part of the question. Now, second part of the question may be, what will be the value of E at a distance 1 meter from the center? That is, R is 1 meter. So second question is how to find out E. E will be Kp upon R cube. If we are having it on axial position, formula is K into 2p upon R cube, which means this will be 9 into 10 raised to power 9 into 2 into value of P is 2 into 10 raised to power minus 2 divided by R, which is given to us 1 meter. So this will be 1 meter cube, that is 1. And we can simplify it. This will be how much? 36 into 10 raised to power 7, which means 3.6 into 10 raised to power 6. Understood?
Yes, sir.
Yes, sir.
I'm sorry, this will be 8. For potential, we have formula K P by R squared. So again, we can find out the value. This will be 9 into 10 raised to power 9. P is 2 into 10 raised to power minus 2, and R is 1 unit in a standard unit. So this will be simply 18 into 10 raised to power 7, or 1.8 into 10 raised to power 8. Understood?
Yes, sir. Yes, sir.
Okay. So this concept is completed. In the next lecture, we will cover up capacitors.
Hello, sir.
Yes. बोलो.
Hello, sir.
हाँ हाँ
Sir,
बोलो.
when we will get the practice question for physics?
प्रैक्टिस क्वेश्चन एक लेक्चर और लगेगा भाई इसमें, उसके बाद भेजता. ठीक है
Okay,
ना?
sir.
कैपेसिटर के बाद.
Okay, sir.
Okay, so in chemistry we will do today redox reaction, what is redox reaction? Redox is a combination of red and ox. Red stands for reduction and OX for oxidation. So redox reactions are the reactions in which reduction and oxidation takes place simultaneously. If there is a chemical reaction in which reduction and oxidation are taking place simultaneously, we call it as redox reaction. So to understand whether a given reaction is a redox reaction or not, we first have to understand what is reduction and what is oxidation. To define reduction and oxidation, we have three different theories. Let me write it all. For reduction or redox reaction, we have three different theories. First one is old theory, which is H and O theory. In this, we will look at reduction and oxidation in terms of hydrogen and oxygen. Second theory is electronic theory. In this theory, we will look at reduction and oxidation in terms of electron transfer. And third theory is, which is more precise, that is oxidation number theory. Oxidation number theory. So first theory is old theory or old concept for reduction and oxidation. And according to this theory, we classify oxidation and reduction as follows. First one, if oxygen is added to some element or any chemical substance, we will call it is oxidation. Or removal of hydrogen is also known as oxidation. Or addition of electronegative element is oxidation, and removal of electropositive element is also oxidation. Opposite to oxidation, we have reduction. In reduction, removal of oxygen will take place or addition of hydrogen will take place. Removal of electronegative element will take place or addition of electropositive element. This is old theory for reduction and oxidation. Let me write one example for it. Let's say we have carbon plus oxygen which gives CO2. In this simple reaction, we have carbon. Before reaction, there is no oxygen atom bonded with carbon. But after the chemical reaction, we have carbon with oxygen atom O. So we can clearly state that oxygen is added to carbon. It means there will be oxidation. And if it is oxidation, the other part will have reduction. So this will be reduction. Understood? Understood or any doubt? Okay.
Understood, sir.
No doubt, sir.
Next is oxidation and reduction in terms of electron transfer. Electronic theory. In this theory, we take reduction and oxidation in terms of electron transfer. Oxidation and reduction. So oxidation will be there if electrons are donated. And reduction will be there if electrons are gained. This is the simple concept in electronic theory for oxidation and reduction. We will look which is donating electron and which is accepting electron. For example, let's say we have a reaction, simple reaction again. Sodium Na react with chlorine Cl2 to give NaCl. In this reaction, you will notice that sodium chloride is formed in which Na is plus and Cl is minus. And in this reaction, sodium donate its electron to chlorine. So sodium loses its electron to form Na plus. Sodium is donating electron, it means it will be oxidation reaction. On the other hand, chlorine accepts this electron and forms Cl minus ion. This will be reduction. Understood?
Yes, sir.
Yes, sir.
And the third and most important part of the theory is third theory, which is oxidation number theory. This is the most precise theory. Oxidation number theory. Oxidation number theory. It simply states that if oxidation number is increasing, then it will be oxidation. And if oxidation number is decreasing, understood? Let's look at reaction of NaCl in terms of oxidation number. This is. So in this reaction, sodium is in its natural form, its oxidation number will be 0. Chlorine is also in its natural form, its oxidation number will be 0. But after reaction, sodium is in +1 form. So its oxidation number will be +1 and oxidation number for chlorine will be -1. So if you will notice at the oxidation number of sodium, it is going from 0 to +1. Oxidation number is increasing in this case, which means there will be oxidation. And in case of chlorine, it is going from 0 to -1, which means oxidation number is decreasing and hence this will be reduction. Understood or any doubt?
No doubt, sir.
Next point is in redox reaction, you will be asked question about which one is oxidizing reagent and which one is oxidizing reagent. So remember, if you are looking for oxidizing agent will be a chemical substance which will oxidize others and it will reduce itself, self-reduce and oxidize other. Third point, if the chemical is reducing itself, will it donate electron or will it gain electron? Self-reducing means reduction is taking place. If reduction is taking place, oxidation number will go down and in terms of electron will be gained by the chemical. So this will be oxidizing agent. In simple words, we state it as जिसका रिडक्शन होता है वो ऑक्सीडाइजिंग एजेंट बनता है. जिसका रिडक्शन होता है वो ऑक्सीडाइजिंग एजेंट बनता है. Right? Next point is about reducing agent. Which will be reducing agent? So first point, this will be the chemical or the element which will reduce others and oxidize itself. Because oxidation is taking place, oxidation number will increase and electron will be donated. In other words, we state it as जिसका ऑक्सीडेशन होता है जिसका ऑक्सीडेशन होता है वो रिड्यूसिंग एजेंट बनता है रिड्यूसिंग एजेंट बनता है आर यू गेटिंग इट आर यू गेटिंग इट
Yes, sir.
Yes, sir.
Yes, sir.
Okay, let's take some example to understand the theory. Let's say we have a simple reaction carbon plus oxygen which gives CO2. In this reaction carbon is added with oxygen, so there will be oxidation, and in case of oxygen there will be reduction. Since question will be like which element is oxidized, so oxidized carbon. Which is reduced is oxygen. Which will be oxidizing agent? ऑक्सीडाइजिंग एजेंट कौन बनता है जिसका रिडक्शन होता है reducing agent will be the one who is oxidized. So oxidizing agent will be oxygen in this case because oxygen का reduction हो रहा है and reducing agent will be the one who is oxidized, that is carbon. Are you getting it?
Yes, sir.
Okay. Let me give one question. Let's say we have a reaction NaOH plus HCl which gives NaCl and H2O. You have to check whether the given reaction is redox or not. So how will you solve it? If there is a question like check whether the given reaction is redox reaction or not, what you have to do is that solve it using oxidation number theory. For that you have to find out oxidation number. So in case of NaOH, in case of NaOH, sodium is +1, hydroxide is OH minus. And if you will go in detail in OH minus, H will be +1, O will be -2. In HCl, H is +1, Cl is -1. NaCl is Na plus, Cl is -1. And in H2O, H is +1 and oxide O is -2. If you will look at different elements, we have sodium, we have hydrogen, we have oxygen, and we have chlorine. What is the oxidation number of sodium before chemical reaction? So before chemical reaction, it is +1. And after chemical reaction, it is again +1. Similarly, for hydrogen, it is +1 before reaction, after reaction is also +1. For oxygen, it is -2 before reaction, after reaction is also +2. Sorry, -2. And finally, chlorine is -1 before reaction, after reaction is also -1. So in this reaction, interesting point is that there is no change in oxidation number of any single element. No change of or no change in oxidation number of any element. Since there is no change in oxidation number, means there will be no oxidation, there will be no reduction, and hence the given reaction is not a redox reaction. Are you getting it?
Yes, sir.
Yes, sir.
If there is a reaction between acid and base, this reaction is never going to be a redox reaction. All the reactions between acid and base, will not be redox reaction. Next concept in this chapter is how to find out oxidation number. Calculation of oxidation number. To calculate oxidation number of any element, you have to remember certain rules. So there are some rules which will help us to find out the oxidation number. First point is all the elements in its natural form will have oxidation number 0. Elements in natural form will have oxidation number 0. For example, if I have sodium element and sodium element is not related or is not bonded with any other element, sodium atom is alone, in that case its oxidation number will be 0. Similarly, it is true for hydrogen. In hydrogen, oxidation number of hydrogen will be 0. In oxygen, oxidation number of oxygen will be 0. This is happening because they all exist in their natural form. Hydrogen H2 is the natural form of H atom, and oxygen atom exists in the form of O2. Similarly, if we are taking ozone, oxidation number of O will be 0. This is first point. In P4, oxidation number of phosphorus is 0. In S8, oxidation number of sulfur is also 0. Now, second point. Second point is about some special elements of group 1 and group 2. So, in second point, we have group number 1 or group number first and group number second. In group number 1, we have lithium, sodium, potassium, rubidium, and cesium. Francium also, but francium is radioactive, so we do not include it in calculation. In group 2, we have beryllium, magnesium, calcium, barium, and radium. Again, radium is radioactive. The interesting point about these elements is that their oxidation number is always fixed. It will not be changed with any element. If group number 1 elements are bonded with any other atom, it may be non-metal or any other form of atom, their oxidation number will always be +1. So oxidation number of group 1 is always +1. And oxidation number of group 2 is always +2. So this oxidation number is never going to change. Now, third point is about hydrogen. Hydrogen can have 3 different oxidation states in different compounds. For example, if hydrogen is in H2 form, oxidation number for hydrogen will be 0. If hydrogen is in hydride form, which is H minus, oxidation number in this case will be -1, and remaining other cases, hydrogen will always be taken as +1. Hydrogen forms hydride only with group 1 and group 2. So if we have group 1 or group 2 and it is reacted with hydrogen, it will form hydride, which means the oxidation state of hydrogen will be -1 if and only if hydrogen is with either group 1 or group 2. For example, let's say we have sodium hydride NaH. So in this case, if you want to know the oxidation state of hydrogen, how will you find out it? Let us consider oxidation state of hydrogen is X plus oxidation state of sodium will be +1 and is equals to net charge on the compound. There is no net charge, so this will be 0. And X plus 1 will be 0, so X will be minus. So in all the hydrides, hydrogen will always have oxidation state -1. Are you getting it?
Yes, sir.
Fourth point is about oxygen. Oxygen can have different oxidation state in different compounds, out of which we have oxide, peroxide, and superoxide. Oxide is given by O-2, peroxide is given by O2-2, and superoxide is given by O2-1. Peroxide can also be given by O-1, and in case of superoxide, this will be -1/2. Understood?
Yes, sir.
In peroxide, we have H2O2. In superoxide, we have superoxides are basically formed by group 1 and group 2 elements. So this will be KO2, NaO2. Now next point number 5 is about ions. What will be the oxidation number of ion? Ions. In case of ions, oxidation number will be taken as simply charge on them. For example, if we have sulfate ion SO4-, in that case, oxidation number of sulfate ion will be -2. Similarly, for carbonate ion, this will be -2. For hydrogen sulfate ion, this will be -1. For hydrogen carbonate ion, this will be -1. For Cn-, this will be -1. Are you getting it?
Yes, sir.
Ni+2 will have +2 oxidation number and Al+3 will have oxidation number +3. Ammonia is neutral, so its oxidation number taken as 0. Similarly, H2O complete is also neutral, its oxidation number will also be taken as 0. Understood?
Yes, yes. Yes, sir.
And we have to remember this.
Yes, you have to remember it. Let's solve some questions. Question is, Find the oxidation number of the following. H2SO4. In H2SO4, we have to find out oxidation number for sulfur. So how will we find out? In this case, we have two hydrogen atom, and oxidation number of hydrogen will be taken as +1 because hydrogen is not with group 1 or group 2. Plus oxidation number of sulfur has to be calculated. We will consider it as X. Plus 4 into oxidation number of oxygen is -2 is equals to 0. So this will be 2 plus X minus 8 is equals to 0. X minus 6 equals to 0. So X will be +6. Remember, in case of redox reaction or in reduction and oxidation cases, if oxidation number of any element is positive, you have to put the plus sign. You cannot just simply say that the oxidation number of sulfur in H2SO4 is 6. You have to state it as the oxidation number of sulfur in H2SO4 is +6. So you have to put the sign, whether it is positive or negative. You cannot eliminate sign by yourself. Let's say we have another acid HNO3. What will be the oxidation of nitrogen atom in it? So we have one hydrogen atom with oxidation number +1. For nitrogen, we have to calculate X plus 3 into, for oxygen atom, we have -2 is equals to net charge on HNO3 is 0. So this will be 1 plus X minus 6 equals to 0. X minus 5 equals to 0. And X will be +5. Again, +5. Are you getting it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Next is, let us say we have a ion, sulfate ion SO4 minus minus, and we have to find out the oxidation number of sulfur. So in this case, sulfur is taken as X plus. For oxygen, oxygen is -2 is equals to net charge on the compound or ion. So net charge on sulfate ion is -2. This will be X minus 8 is equals to -2. X will be -2 plus 8. So finally X will be how much? This will be
Plus
+6.
6.
Understood?
Yes,
Yes,
sir.
sir.
If we have KMnO4, what will be the oxidation of Mn in this? You have to solve it. And for K2Ci2O7, solve for Cr. So this will be your homework. First, second, third, CO2, calculate the oxidation number of carbon. Fourth, H2H2O7, find the oxidation number of sulfur. Fifth, HClO4, find the oxidation number of Cl. Understood, or do you have any doubt? Yes?
No doubt, sir.
Okay. Next point in this chapter is balancing of chemical equations, which I'm not going to tell you the traditional method. What will we do is that we will just go by option. We will substitute the option in the equation and check whether the atoms are balanced on both sides or not. So we will not do it in traditional way. Understood? So this chapter is also completed. In this chapter, the question will be only of two types. Either you have to select oxidation reduction or oxidizing agent and reducing agent. And second type will be for the calculation of oxidation number. Third is balancing which will be done by the option. Anyone has any doubt?
No, sir.
So could we start maths?
Yes, sir.
Yes, sir.
Yes, sir.
We have done some of the concepts of determinant, right?
Yes, sir.
In maths, we are doing determinants. And in determinants, I think some of the properties of determinants have been completed. Okay, so we have done three properties. Have we done adjoint? Yes.
Yes, sir.
Adjoint is
Yes, sir.
completed. Okay. Minor cofactor is done. Properties of adjoint is not completed, right?
Yes, sir.
Okay. So we will do properties of adjoint. This is very important topic. Very, very important. So questions will be from here. Properties of adjoint of a matrix. ठीक है बैच 4 बैच 5 नीचे चले जाओ टीवी रूम में so we have two matrix A and matrix B which are non singular matrix A matrix B are non singular means determinant of matrix A is not 0 determinant of matrix B is not 0 and inverse of matrix A and matrix B exists this is what do we mean by non singular matrix. Now about these non-singular matrix, order of both the matrices is n. Order is n. Order is n means it is n by n. First point is if you want to have A multiply adjoint A, so A times adjoint A will be same as adjoint A times A, which will be determinant A times I. I is identity matrix here and determinant of matrix A. Second point is, if you take adjoint of transpose of a matrix, this will be same as adjoint of A transpose, which means either you first take transpose of matrix and then find out the adjoint, or you can simply find out the adjoint directly and after that you can apply the transpose. Answer will be same. Third property is very important. This property states that if we have two conformable matrices for multiplication AB and adjoint AB has to be calculated. So in this case, adjoint will be applied to both the matrices or can be distributed to them, but in reverse direction. So if A is first and B is last, then you will distribute adjoint, it will be adjoint B into adjoint A. Are you getting third property? Yes or no?
Yes, sir.
Yes, sir.
Fourth property is adjoint scalar K times matrix A. So matrix A is multiplied by some scalar K, and after that we have to find out the adjoint. So adjoint of Ka will be equals to K raised to power n minus 1, where n is order and times adjoint A. So adjoint Ka will be equals to K raised to power n minus 1 adjoint A, and K belongs to R, which means K is a real number, and I would say it will not be 0, because if it is 0, everything will be 0. Next is number 5, which states that adjoint of A raised to power m can be written as adjoint A raised to power m. Sixth property is adjoint of adjoint A. This is very important property. Sixth one. Adjoint of adjoint A can be given by adjoint of adjoint A can be given by determinant A raised to power n minus 2. Determinant A raised to power n minus 2 into matrix A. Number 7, if you want to have determinant of adjoint of matrix A, so determinant of adjoint A will be equals to determinant of A raised to power n minus 1. And if you want to have determinant of adjoint of matrix A, then this will be determinant A raised to power n minus 1 to the whole square. Ninth is adjoint of identity matrix of order n is In, that will be identity matrix itself. And if you are taking adjoint of a zero matrix of order n, null matrix, adjoint will be 0. Understood? Some important points. First one is, if we are taking adjoint of a diagonal matrix, the resultant matrix will also be a diagonal. So I will write it as adjoint of a diagonal matrix will be a diagonal matrix. Second, adjoint of a triangular matrix, whether it is upper triangular or lower triangular, will be triangular matrix. And third is adjoint of a symmetric matrix will be a symmetric matrix. Understood or any doubt? Yes. Next point is inverse of a matrix and its properties. Inverse of a matrix and its properties. So let's say we have a matrix Aij of order n into n, which is a square matrix, and I want to know whether this matrix A has inverse or not, or in other words, we want to know whether the matrix A is invertible or not. So to know the behavior of matrix A, we have to find out determinant of matrix A. And if determinant of matrix A is not equals to 0, it means A is invertible matrix. A is invertible matrix. We call it non-singular, which implies that A inverse exists. A inverse exists. If A inverse exists, it has to be a new matrix B. So let's say there is another matrix B, Bij of order n into n, such that AB is equals to BA is equals to identity matrix. If this is the case, we say that B is the inverse of A and A is the inverse of B. To calculate inverse of a non-singular matrix, we have a standard formula. A inverse of a non-singular matrix can be given by adjoint A divided by determinant A, provided that determinant A is not 0. Because if determinant A will be 0, it will not be possible for us to calculate the inverse of a matrix. This statement also indicates that every square matrix will have inverse. It is not true. A square matrix may or may not have inverse. It may or may not have inverse. It will depend on the determinant of the matrix. If the determinant of the square matrix is not 0, it will definitely have an inverse. And if the determinant of the square matrix is 0, in that case, it is a square matrix, but it does not have inverse. Are you getting it? So every square matrix does not have inverse. Next point is about the properties of inverse. Properties of inverse of a matrix. First point is A inverse will be A, which simply means if you take the inverse of a matrix odd times inverse, answer will be A inverse. And if you take inverse even times of a matrix, even times inverse, in that case, answer will be matrix A. Second property is if we have two matrix conformable for multiplication A and B, and we are in multiply and we have to find out AB inverse. So inverse will be applied to both the matrices, but in reverse direction. This will work same as transpose, adjoint, and inverse do. Transpose will also be in multiplication go in reverse direction. Adjoint also will be in reverse direction, and inverse will also be working as in reverse direction. So AB inverse will be equals to B inverse into A inverse. Next we have third property is if we are taking A1 multiply A2 multiply A3 dash dash AN matrices and taking inverse of them, so this will be AN inverse into AN minus 1 inverse dash 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 A3 inverse, A2 inverse and A1 inverse according to property number 2. Now in property number 3, if you will take A1 equals to A2 equals to A3 equals to dash dash AN, it will give an interesting result which will be A multiply A multiply A multiply A n times A raised to power n with inverse, and on the right hand side it will be A inverse A inverse A inverse multiplied with n times, so this will be A inverse raised to power n. This is a very important property. This property indicates that if you are given with a matrix A and you have to find the inverse of A cube or A raised to power 4, first of all you can simply find out the inverse and then you can multiply it, which means power and inverse are interchangeable. They can be interchanged. Understood?
Yes.
Next property is number 4, which is determinant of A inverse is same as determinant A inverse, which will be 1 by determinant A. This is again important point. Number 5 is inverse of transpose matrix will be same as inverse to the transpose, which clearly indicates that transpose and inverse are interchangeable, same as power and inverse are interchangeable. Next point is number 6, A multiply A inverse or A inverse multiply A obviously will be I. This is basic definition. Next point is number 7. If we have a matrix A, which is a diagonal matrix, 1 A 0 0 0 B 0 0 0 C, this is a diagonal matrix of 3 into 3 order, and you have to find out A inverse. So in this case, A inverse will be the inverse of diagonal element. So A will be 1 by A 0 0 0 1 by B 0 0 0 1 by C, which clearly implies that the effect of inverse on diagonal matrix will be given in diagonal elements. So if we are taking inverse of a diagonal matrix, we will just take the inverse of diagonal element. So this will be inverse of A, inverse of B, and finally inverse of C. Understood or any doubt? Yes. Okay. Let's do some questions related to determinant. First question is very easy. Find the value of determinant 2, 4, minus 5, minus 1. Options are 18, 22, minus 18, 16. So this is straightforward. This will be determinant of matrix A. 2 into minus 1 cross multiply minus 5 into 4. So this will be 2 into minus 1 minus 2. This will be plus 20. So determinant of A will be 18. Option A will be correct answer. Understood?
Yes, sir.
Next question is find the value of cos theta minus sin theta, cos theta. Let me name it as matrix B. So what will be the value of this matrix? Options are 1, -1, 2, 0. So matrix B will give determinant as B, and this will be cos theta into cos theta, cos square theta, minus sin theta into minus sin theta, minus sin square theta. So determinant of matrix B is cos square theta plus sin square theta, which is 1. So answer will be 1, which means option A is correct. Another question is find the value of determinant x square minus x plus 1, x minus 1, x plus 1, x plus 1. So how will you solve it? Option A is x cube minus x square plus 1. Option B is x cube minus x square minus 2. Option C is x cube minus x square plus 2. Option D is x cube minus x square plus 12. Now in this question, the value of determinant is given in the form of x, which indicates that the value of determinant will depend on the value of x. If we will change the value of x, value of determinant will be changed. So there are two methods to solve this question. First is you can go by expansion, direct expand the given determinant and simplify it to get the answer. Or another alternative approach may be, which is I think will be far more better. You just take any arbitrary value for x. Let's say I take it as 0. Now put x equals to 0 into the determinant. This will be 0, this will be 0, this will be 1, this will be -1, this will be 1, this will be 1. Now what will be its value if you will solve it? This will be 1 plus 1, that is 2. So that option will be correct option, which will give value 2 on putting x equals to 0. So if I put x equals to 0 in this equation, it will not be 2. If I put 0 here, it will not be 2. If I put 0 here, it will not be 2. So we are left only with C option. The correct answer will be C. Are you getting it? What is the concept?
Yes, sir.
Sir.
So
Yes, sir.
remember if there is a question in such type that there are certain arbitrary variable in determinant and the same variables are coming into the option. So you can always go by substitution. Take any arbitrary value and just simplify the determinant. And for far more easier calculation, we basically select 1, 0 and -1. These three values will give the answer. Understood?
Yes, sir.
Okay, next question is find the value of x if 2451 is equals to 2x for 6x. Options are option A, x is root 3. Option B, x is plus or minus root 3. Option C, x is minus root 3. Option D, none of these. So again, this is a straightforward question. Just simplify the determinant. So this will be 2 into 1 minus 5 into 4 equals to 2x into x, 2x square minus 6 into 4, 24. So this will be 2 minus 20 equals to 2x square minus 24. This will be minus 18 plus 24 is equals to 2x square. So 2x square will be equals to how much? Yes, how much?
Plus minus root 2.
So x square will be 3 and x can be given as plus minus root 3. So correct answer will be B option. Next question is evaluate determinant 3 minus 1 minus 2 0 0 minus 1 3 minus 5 0. You just have to simplify it. So this is a 3 order 3 into 3 determinant and we have to solve it. So either we can go by direct expansion by any of the 3 rows or any of the 3 columns. But in this case, second row has 2 zeros and that row or column which has more number of zeros will give answer more rapidly. So we will expand this determinant according to R2. So on expanding according to R2, convention will be plus minus plus minus plus minus. So first element will be 0, whatever will be the result, this will give 0 output, this will give 0 output. So we have to calculate only for minus 1. So element is minus 1, convention is minus, so this will be 1. And to simplify it, we have to delete the corresponding row and column. So 3 will be multiplied with minus 5, that is minus 15. And this 3 will be multiplied with minus 1, that will give minus 3 with minus sign already will be plus 3. So determinant in this case will be minus 12. Are you getting it?
Yes, sir.
Okay. Next question we have. Again, we have to evaluate determinant 3 minus 4 5 1 1 minus 2 2 3 1. What will be its value? Options are 45 20 46 14. How will you solve it? Yes. सिंप्लीफाई करें इसे. Yes, आया क्या आंसर?
Yes, sir. 46.
Yes, how much?
Sir, 46.
46. That is C option. How will you solve it? Just simplify it. According to R1, if you will expand, you will get 3. This will be deleted. This will be deleted. 1 plus 6. Minus 4 will be plus 4. Convention ke according. So this will be 1 plus 4 plus 5. 3 minus 2. So answer will be 7 into 3, 21 plus 20 plus 5. So this will be how much? 46, I think. So correct option will be C option. Understood or any doubt? Next question is, if 2, 3, 4, 5 is equals to x3 to x5, what is the value of x? Option A is 2, option B is 3, option C is 4, option D is 5. So again, this is very simple to solve. This will be what? 2 into 5,
X
10
equal to
minus 4
2.
into 3, 12. And this will be 5x minus 6x. So minus 12 will be minus x. Sorry, minus 2. 10 minus 12. Na? This will be minus 2. So x will be 2. Yes or any doubt?
No, sir.
Okay. So this is find the value of determinant A minus B, B minus C, C minus A, B minus C, C minus A minus B, C minus A minus B, and B minus C. You have to find out its value. Options are 1, 2, 3, and 0. So how will you solve it? See, in this question, determinant which is with values A, B, and C, or arbitrary value of A, B, and C, is giving some constant value. Either it is 1, 2, 3, or 0, whatever be the answer. But the point is, this is going to be a constant K. If the right hand side is a constant, it clearly indicates that on the left hand side, it doesn't matter what is the value of variable you are selecting. Are you getting my point? Yes.
Yes, sir.
If on right hand side we are having a constant value, it clearly indicates that it doesn't matter what we select for A, B, and C. The output has to be same value for all possible values of A, B, and C. That is what do we mean by constant K. So if I select certain values of A, B, and C, I think this will be 0. Because if you take A, B, C as 0, this will be 0. If you take A, B, C as 1, so A, B, C as 1 will be 0, 0, 0. Again, answer will be 0. But to be more sure, let us take some different numbers. Let's say I take A as 2, B as 1, and C as 0. What will be the answer in this case? So this is A minus B, which means 2 minus 1, 1. B minus C, B minus C means 1 minus 0, 1. C minus A, 0 minus 2, minus 2. B minus C, 1. C minus A, minus 2. A minus B, A minus B, 1. C minus A, minus 2. A minus B, A minus B, 1. B minus C is 1. Simplify it. So we will take 1. We are expanding it according to R1. Right? We are expanding it according to R1. So if we will take R1, this will be 1. This will be deleted. This will be minus 2 and minus 1. Minus 1. This will be deleted. This will be 1 plus 2. And then we will have minus 2. This will give us 1 and minus 4. So in this case, what will be the answer? This is minus 2 minus 1 minus 3. This is 2 plus 1, 3 into minus 3 minus 3. 1 minus 4 minus 3 minus 3 into minus 2 is plus 6. Answer is again 0. So I have taken 3 different cases. I have taken A equals to B equals to C equals to 0 and A equals to B equals to C equals to 1 or any other possible values, or you can take any other combination also. In all these cases, answer is always coming to be 0, which clearly indicates that the constant value is 0. It also implies that in this question, it doesn't matter whatever be the value of A, B, and C, the output is always going to be 0, which means this determinant is always 0 for all possible values of A, B, and C. No matter whatever value you will select from real number, this determinant will still be 0. Understood or any doubt? Yes?
Understood, sir.
No
Okay,
doubt, sir.
now next question is, what is the value of determinant 1, 1, 1, B, C, C, A, B, A times B plus C, B times C plus A, and C times A plus B. Options are 1, 0, 3, minus 1. Now, there are two different ways to solve it. Either you can expand it directly, expand it by using traditional method, or you can select certain values for A, B, and C. So if you will take A as 1, B as minus 1, and C as 0, put all these values into the determinant and solve it, you will get certain fixed value, and that will be the answer. But let me do this question by a different method. So in this case, we are having here 1, 1, and 1. To simplify it, we can make here 0 and 0 by using transformations. Do you know how to transform a determinant? Do you know anyone? Let
Yes,
me
sir. By
write
row
it out.
column operation.
Yes. R1 will be given as R1 minus R2, I think. Or let me do it with the help of R3. No, this will be better for R2. So R1 will be what? This will be 1 minus 1, 0. BC minus CA will be C into B minus A. And AB plus AC, if you will subtract it from BC and AB. AB will cancel out. So we will be left with AC minus BC. That is C times A minus B or minus times B minus A. Am I right? Yes or no?
So can you repeat it once?
Okay. 1 minus 1 will give 0. BC minus CA, we will take C common. So this will be B minus A. And in this is AB plus AC. And this is BC plus AB. So if we will subtract AB plus AC minus BC minus AB, AB will cancel out. So we are left with AC minus BC. We will take C common, it will be A minus B. And if I will take minus outside, this will be B minus A. Understood?
Yes, sir.
Yes, sir.
Now we will do a change in R2, that is R2 minus R3. This will be 0. This will be CA minus AB and A will come out. This will be C minus B. Now this will be BC plus AB and AC plus BC. So in this case, BC will cancel out and we will be left with AB minus AC. AB minus AC, if we take minus A common, we are left with C minus B. And third row will be as it is. Right? Now you can take common outside from this and this. So this will be what? 0, 1 minus 1, 0, 1 minus 1, 1, AB, C into A plus B. And outside there will be some factors which will be C into B minus A and A into C minus B. If we will again add column 2 and column 3, this will give 0, 0, 1. This will give 0, 0, AB plus AC plus BC and minus 1, AC plus BC. Now if you will expand it, plus minus plus, so this will be minus 1. This will be deleted, this will be deleted. This will be 0, this will be 0, overall will be 0. So answer will be again what? 0. दिखना नहीं मतलब बस ठीक है इधर तो है चलो इधर देखो क्या प्रॉब्लम है any doubt in it
No, sir.
you can also go by direct substitution that will be far more easier for you right you can take A equals to B equals to C equals to 1 so this will be 1 1 1 two column is identical will be 0 that is also a way to do but
Yes,
to
sir.
be sure we can take different values because if you are taking same values maybe this is a special case so to be 100% sure we can take different values in that case whatever will be answer that is final understood
Yes, sir.
Yes, sir.
okay
Yes, sir.
और now we will take a topic from general aptitude in last session we have done time and work in general aptitude and in today's lecture we will do time and distance or in simple words let me write it as speed distance and time this is basically a concept of physics Question will be straightforward. You just have to remember the formula. What is the formula for speed? And what are the corresponding relations which we can obtain from it? That is all. So, do you know what is the formula for speed? Yes. Password. किसका? इधर देखो ना, ये लगेगा क्या? मीटिंग करनी चाहिए. Yes, anyone? What is the formula for speed?
So distance upon time.
Distance upon time. The simple concept. The first point is speed is equals to distance upon time. As a consequence of this formula, we can clearly state that distance will be speed into time, and time will be distance by speed. It's straightforward. There is nothing to explain in it. Question will be directly based on the formula. Okay, so next point is, if we are given speed in kilometer per hour and you have to convert it into meter per second, how will you convert it into meter per second? Multiply by 5 by 18. Yes. So remember that if we are given x kilometer per hour, if you will multiply it by 5 by 18 factor, this will be in meter per second. And if it is x meter per second, hello, जी मैम, किधर? ये लेक्चर लेने के बाद जाता ना, ठीक है. X meter per second, if it is given in x meter per second, then multiply by 18 by 5. This will be in kilometer per hour. Next point is ratio of time. If the ratio of speed is A is to B for same distance, then the ratio of time will be 1 by A is to 1 by B, or B is to A. Next point is important. Let's say this is certain distance and this distance is divided into two equal half distance. First half is covered by speed x kilometer per hour or x unit, maybe kilometer per hour or maybe in meter per second. Second half is covered by y unit. What will be the average speed? So average speed in this case will be average speed in this case will be 2xy divided by x plus y. Understood? Next, if a person is moving in this direction with velocity u, another person B is also moving in the same direction with speed u, what will be their relative velocity? So relative velocity. Do you know what will be the relative velocity? It's simple physics. Relative velocity of A with respect to B will be V minus U, and relative velocity of B with respect to A will be U minus V. Next point is, if they are moving in opposite direction, person A with speed V, person B with speed U are moving in opposite direction to each other. In that case, relative velocity for both of them will be V plus U. Relative velocity of A with respect to B, relative velocity of B with respect to A will be V plus U. Understood or any doubt?
No doubt, sir.
Last point is, this is a trick. If two persons A and B start at the same time, in opposite direction, from 2 points, and after passing each other, they complete the journey in A and B hours, respectively. Then what will be the ratio of A's speed to B's speed? Speed of A to speed of B. So this will be given by direct root B to root A, where A complete its journey in A time and B complete its journey in B time. So ratio of their speed will be square root of B to the square root of A. So these are certain few points which can be remembered. And now we can directly solve the question. The core concept is speed equals to distance by time. That is the core concept. Apart from that, you must know the concept of average speed. Basic formula for average speed is total distance divided by total time taken. That is the core formula. Now let's solve question number 1. Question number 1 is, a train travels 82.6 km per hour a train travels 82.6 kilometer per hour. How many meters will it travel in 15 minutes? Yes. How many? Anyone? Speed is given to us 82.6 kilometer per hour, and we have to find out in 15 minutes how many meter will be covered by it. So let's look at the speed. Speed is 82.6 kilometer per hour, which means in 1 hour it cover 82.6 kilometer. 1 hour means 60 minutes. In 60 minutes it cover 82.6 into 1000 meter. This much. What will be for 1 minute? This will be 82.6 into 1000 divided by 60. And we are given with 15 minutes. So for 15 minutes, answer will be 82.6 into 1000 divided by 60 into 50. 15, sorry. I think this will be 4 times. Yes. And now if we will simplify it, this will be how much? This will be 4 to the 8.
20,650.
This will be
20,650.
right. Next question is, how many minutes does Aditya take to cover a distance? Distance is given to us, that is 400 meter. If he runs at a speed is given to us 20 kilometer per hour. Question is, how many minutes does Aditya take to cover 400 meter if he runs at a speed of 20 kilometer per hour? So how will you solve it? We have to find out time. Time is distance by speed. Distance is in meter and speed is in kilometer per hour. So what we can do is that we can convert kilometer into meter, right? So if I will find out time simply will be distance by speed. Distance is 400 upon speed is 20 kilometer per hour. Let's convert kilometer into meter. This will be 1000 meter per hour. Now this will cancel out. 2 to the 4. Or let me write it as 5. So time will be 1 by 50 hour. Am I right? Yes, check the calculation.
Yes, sir, it's correct.
Next question is, a cyclist covers a distance of 750 meter in 2 minutes 30 seconds. So distance covered by cyclist is 750 meter. Time taken by him is 2 minutes 30 seconds. You have to find out the speed in kilometer per hour. What will be speed in kilometer per hour? Yes. Solve it. Solve. How will you solve it? Yes, any idea how will you solve it? Distance is given, time is given, speed we have to calculate in kilometer per hour. So first of all, we can find out speed in meter per second. Because distance is in meter, time can be converted into second. So let's say distance D is 750 meter. Time is 2 minutes. 2 minutes means 2 into 60 seconds plus 30 seconds extra. So I think time will be 120 plus 30, 150 seconds. So in this case, speed is distance by time, where distance is in meters, and time is in seconds. This will cancel out. So this will be 5 meter per second, right? We have to convert it into kilometer per hour. So to convert it into kilometer per hour, what factor will be multiplied? 18 by 5. 5 factor will cancel out. So answer will be 18 kilometer per hour. Understood or any doubt? Yes, any doubt?
No, sir.
No, sir.
Okay. Next question is, this is little bit difficult. A man, a man walked at a speed of 4 kilometer per hour from point A to point B. Point A to point B. And came back from point B to point A at the speed of 6 kilometer per hour. At the speed of 6 kilometer per hour. Right? What would be the ratio of time taken by the man in walking from A to B and from B to A? So basically, we have to find out time ratio. What time ratio? We have to find out the ratio between time taken to go A to B and time taken to come back B to A. What will be the answer? So you know that speed is equals to distance by time, right? And time is distance by speed. Because person is going from A to B and coming again from B to A. So in this case, D will be the same, distance is fixed. D constant हो जाएगा यहाँ, right? Because the whole journey is between 2 point A and B. So the distance between point A and B will be a constant value, which simply means that if you will consider D as constant, T will be inversely related with B, which means time taken to go from A to B will be directly proportional 1 upon V when it goes from A to B. And T B to A is directly proportional 1 upon V B to A, which clearly states that if you are taking ratio, this will be 1 upon 4 is to 1 upon 6 or 6 is to 4. Understood or any doubt? Yes.
No doubt, sir.
Common factor can be cancelled out. So this will be 3:2. Next question is, interesting question. 200 में आया. Simple the question है. A trip to a destination is made in the following way. So there is a trip, and this trip is completed in 3 different modes. First part of the trip is 900 kilometers by train. Second part of the trip is, and the speed of train is 60 kilometer per hour. Second part of the trip is 3000 kilometer by plane. Speed is 500 kilometer per hour. भाई बात मत करो आप लोग. Third part of the trip is 400 kilometer by boat. Speed is 25 kilometer per hour. And finally, fourth part of the trip is 15 kilometer by taxi with speed 45 kilometer per hour. You have to find out average speed for the entire journey. ये क्वेश्चन को देख के ऐसा लग रहा है घूमने वाला बंदा कुछ ज्यादा ही अमीर है. ट्रेन, प्लेन, बोट सब से घूम रहा है. Okay, so what is the formula for average speed? Average speed is nothing but total distance upon total time. That's it. So we have to get two information: overall distance and overall time. Overall distance is very easy to calculate because we are directly given with 900 kilometer, 3000, 415. So this will be 900, 3000, 400 plus 15. Now what will be total time taken? Because a different part of the trip or different segment of the distance is covered by different speed. So time will be different. For example, in case of train, time will be 900 divided by 60 because time is distance by speed. This is distance, this is speed. And in this case, time will be 3000 divided by 500. In this case, time will be 400 divided by 25. And in this case, time will be 15 by 45. So what will be total time? Total time will be 900 divided by 60 plus 3000 divided by 500 plus 400 divided by 225 plus 15 divided by 45. Now simplify it. So in numerator, what will be the overall distance? Yes, overall distance in numerator will be how much? This will be 3900, 4300 and 15. So this will be 4315 kilometer. What will be the time taken? So if you will simplify it, this will cancel out. This will be 3 3 ja 9, 3 2 ja 6. This will be 15 plus 2 0 will cancel out. This will be 60 plus 5 8 ja 5 5 ja 16 85 16 plus 15 by 45 will be 1 by 3. So this will be how much? This will be how much? Help me please. Calculation करें आप लोग. ये कितना हो गया? 60 plus 15 75 and 16.
Sir, it's
91.
about 37.33.
37.33.
33,
Now simplify it. So
which
this
is
will
equal
give
to
us
115.59.
100.
15.59.
Okay, 115
.59.
kilometer per hour. Okay. Next question is Peter Parker can cover a certain distance in 1 hour 24 minutes by covering by covering two-third of the distance at 4 kmph. 4 kmph means 4 kilometer per hour, and the rest at 5 kmph. Find total distance. Find total distance. So how will you solve it? There is a distance which is covered in overall time 1 hour 24 minutes, and this distance is covered by two different modes. One is two-third part of the distance by 4 km per hour and remaining distance by 5 km per hour. So what is the total distance? So let us take total distance is x kilometer. First part, that is two-third of x, is covered by 4 km per hour. What will be the remaining distance? If total distance is x and 2 by third is covered, so we are left with x minus 2 by third of x, that is 1/3 of x. And this distance is covered by 4 km per hour. And to cover the complete distance, overall time is taken 1 hour and 24 minutes. So this will be 1 hour plus 24 minutes divided by 60. 2 by 5. So total time in hours will be 7 by 5 hours. Am I right? Now, total time will be equal to time taken to cover two-third distance plus time taken to cover one-third distance. Total time is 7 by 5. Time is distance by speed. So distance is two-third of x divided by speed is, in this region, speed is 4, plus in case of one-third, speed is 5. So just simplify it. This will be how much? 7 by 5. And I think this will be x by 6. This will be x by 15. Right? Okay. Now take x common. This will be 1 by 6 plus 1 by 15. Simplify. 7 by 5 is equals to x into. This will be 15 plus 6 divided by 15 into 6. 7 by 5 x into 15 plus 6, 21 डिवाइडेड बाय 15 into 6 नहीं हो रहा उधर, कुछ तो प्रॉब्लम है आज। 15 into 6 is how much?
90.
90. This will be 7 3 ja, 3 3 ja, 5 6 ja. So overall answer will be 6. Understood?
So can you please repeat?
From where? Calculation or the upper part?
Sir, after t equal to t2, t2 by
Okay.
3 plus.
Total time is 7 by 5 hour, and this total time is distributed in the journey in two different parts. So overall time is equals to time taken to cover 2/3 of the distance plus time taken to cover 1/3 of the distance. So this will be overall time 7 by 5, and general formula for time will be distance by speed. In the first case, distance is 2/3 of overall distance and speed is 4. In the second case, remaining distance is 1/3 of the overall distance and speed is 5. So if you will adjust it, 2 will divide 4 by 2 times, 3 will be in denominator. So this will be x by 6, this will be x by 15. Then we will take x common. It will be 1 by 6 plus 1 by 15. Then we will simplify x by 1 by 6 and 1 by 15 by LCM. So this will be 7 by 5 equals to x into 21 by 90, and then simplification will give 6 unit answer. Understood?
Yes, sir.
क्या डेट है भैया? 8 है ना? किसी को कोई डाउट है यहाँ तक? क्यों तुम लोग राक्षस बनने पे उतरे रहते हो हमें? भाई ये पीडीएफ भेजा है ये आज का, चैट बॉक्स में देखो, मिल जाएगा आपको, डाउनलोड कर लो वहां से। डाउनलोड कर लो अभी, फिर ग्रुप में डालते रहते हो आप लोग, पीडीएफ भेज दो।
सर
यस।
सर प्रैक्टिस क्वेश्चन कब मिलेगा?
प्रैक्टिस क्वेश्चन आज भेज दो भाई। बुक नहीं है तुम्हारे पास कोई?
सर आवाज नहीं।
क्या कंप्लीट हो गया? कंप्लीट हो गया तो क्या सेंस है चैप्टर पूछने का? अगले लेक्चर में मिलते हैं।